So yeah, this talk is, I'm Benny Grins. I'm the chief scientist co-founder at Espresso Systems. I also moonlight as a cryptographer at NYU. But this talk is not going to be about cryptography. It's going to be about sequencing, but actually under the hood, I won't talk about it, but there's a lot of use of cryptography and encryption and for example, private auctions that is very applicable to this. So what are rollups? Well, rollups, or what's the goal of rollups? Well, the goal of rollups is to scale Ethereum or to scale a layer 1 blockchain horizontally. And essentially, we have application layer servers. So you could imagine this being different applications or even full virtual machines that process applications. And it has several advantages where we can have powerful servers. And these servers do the computation, and then a weak layer 1, so for example, a smart contract, can verify the computation without having to redo the entire computation. And this is supported by proofs, either cryptographic ones or fraud proofs. And there's several benefits of this. You can shard the computation, so if one application is congested, it doesn't affect the other computations as much. And secondly, you can also have a great diversity of virtual machines. So each application or each rollup can be specialized to a different application. However, there's also a problem with it, which is that if we think about the core value proposition of Web3 and Ethereum, the value proposition is in its unity. It's that I can write an application and it can seamlessly interact with all the other applications that have been written without the applications even being aware of it, or without there having to be some sort of peer-to-peer contract or some intermediary layer. And the seamless interoperability of applications is the promise of this trust web minimized infrastructure, and it is exactly the difference between what we can get in Web3 and what we have in Web2. So let's to unveil like the problem, how rollups address this problem today and how we can hopefully address it in the future, we have to dive a little bit more deeper, and in particular we have to look at this node called the sequencer. So this is the node that basically collects and orders the transactions. That's essentially all it does. It basically determines the rollup blocks, and then it posts a summary of these transactions along with a proof to the L1. So rollups today run isolated sequencers. So each one of them has an isolated and centralized sequencer. And this has a lot of drawbacks. And I can't go into all of the details of this, but essentially it basically significantly hurts the interoperability. If I have funds on one rollup, I first need to bridge them over to the L1 and then maybe back to the other rollup, or I need to have some sort of liquidity provider that borrows me money and takes a fee for it. But essentially, these rollups are very, very isolated. So they sort of hurt the promise that we've originally wanted from Web3. And ultimately, what users want is they want a secure, convenient, low-cost experience with the interoperability. So they want both the scalability that rollups have, but ideally without losing the interoperability that we're used to from Web3. And one of the advantages, so one of the things that the rollup sequencer can do is it can promise you that it will execute some transaction, or the sequencer can promise you that it will execute some transaction before it even has posted the block to L1. However, the problem is, what if I want to execute two transactions, one on one rollup and the other one on another rollup? So I want two transactions to execute atomically. I either want both of them to happen. So for example, I buy some asset on one rollup and I sell the asset on another rollup. And I either want them both to happen or none to happen at all. And the problem is that, if I have two rollups, then say I have two rollups, then nobody can, and they have isolated sequencers, then nobody really can make that promise, right? There's no person here, unless these sequencers somehow coordinate, there's no person that can make these atomic promises. Because these rollups may not even be synced, the rollups may happen in different orders. So for example, the state of one rollup may change before the transaction happens, and so on and so forth. Like the price on the AMM may have changed. So what we want is that we have basically shared proposers. So a shared proposer wait, I'll go over this. So ideally what we would want is a shared proposer that can propose for multiple rollups at the same time. The problem is who's going to execute that role? Is now suddenly Arbitrum going to use Optimism sequencer? That doesn't seem very likely. Is everybody just going to agree on one party to run the sequencer? Also, that would lead to a high level of centralization where this one sequencer has all of the control, so it can, for example, censor transactions. So can we do something better than that? So our solution to this is to build a marketplace where rollups can sell their sequencing rights. The other important factor is that these sequencers can make money through MEV or through collecting sequencing fees. So rollups don't want to give up that right. But what we can do is that rollups, instead of giving up that right for free, what if they're willing to sell it? And these rollups are, so now we have different sequencers, and they can bid on these different rollups and buy them. But one important artifact of our marketplace is that rollups are allowed to buy multiple sequencers. That sequencers are allowed to buy multiple rollups at the same time. So I can, for example, say that rollup A is worth 3 to me and rollup B is worth 4 to me, but together I would be willing to pay 10, because, for example, I can satisfy cross rollup intents if I control both sequencers at the same time. So if we look at an example here, now we had these bits, and then we run the marketplace, and we get some allocation of these rollups to different sequencers. So, for example, here the one on the left, one Arbitrum, and then there's one on the right that won multiple rollups at the same time. So now, and this marketplace is run for one time slot in a row, so we run it very often. But for that time slot now, the yellow sequencer controls 3 rollups. And what this means is it controls the state of 3 rollups, so it can promise atomic execution, and it can actually enable synchronous composability between transactions on all of these rollups, because it can literally create one super block for all of these rollups at the same time. So the goal of the marketplace is that we can enable sequencers to temporarily become shared sequencers for all the rollups it purchased in the marketplace, and they can create a super block. However, this is a shared sequencer where the rollups don't have to give up sovereignty. They only sell their sequencing rights, and they only sell it for a temporary amount of time. And in fact, they can put additional restrictions on it. So one of the goals, for example, in the marketplace is you might say, I only want to sell my rollup to a pre-selected, I want to basically KYC the bidders, or I want to, I don't know, do some sort of restrictions, and I don't want to say like anybody can buy it, but these rollups basically retain their sovereignty and can basically say who they're willing to say it to. Of course, the more they open it up, the more competition there's going to be, and the more money the rollup will make from selling their sequencing right. So one problem with this design is that we don't necessarily know that all the bidders and all the buyers are necessarily going to be honest. So right now, the sequencers are essentially trusted entities, right? They have a high reputation. If a sequencer is usually run by the protocol itself, and of course it could be malicious, but we see very few instances of these sequencers being malicious because they have a very high reputation that they have to uphold. And if they did any malicious actions, if they went down, then the community would be very upset. However, now we can have temporary buyers of a rollup. So we don't have the same reputation anymore. Someone could possibly do a malicious action and then just vanish. So we need to at least consider this case. So what can this malicious buyer do? Well, we cannot necessarily trust it. We could add some reputation system. That's sort of an intermediary solution. We add some reputation system, but it's not perfect. So we at least should analyze what happens if the buyer is malicious. Well, it turns out that a sequencer that submits an L1 block with proof, there's a lot of things they cannot do. So they, for example, cannot steal funds, because they have to submit a proof. If they try to steal funds in some way, then the proof would be invalid or they would get caught with a fraud proof. So we're good on that end. And they also cannot block transactions forever because we run the sequencing marketplace many times, and we can basically, at some point, someone else is going to win the sequencing right and can basically unblock the transactions that were blocked. And additionally, there's further solutions such as inclusion lists that further help with this censoring or blocking of transactions. However, what they can do is they can delay transactions. So they can, for example, simply in a slot not sequence a transaction, or they can order things in a way that's preferable to them. And additionally, they can give bad pre-confirmations. So they can give a pre-confirmation, they can promise you that they will include something, and then not actually do it. We might be able to slash that offense, but of course, if they can gain more from doing this action than what they risk slashing, they might still be willing to do it. So how can we prevent against that? Well, our solution is that we can add a finality gadget. So one problem with this design is that these rollups have to post these blocks to the layer 1. However, this takes time, and there's actually a lot of efficiencies that come from aggregating transactions and waiting until you, for example, have a full blob, and you really want to wait a little bit until you, for example, you've finished your proof and you can post this transaction to the L1. But what we can do is we can add a so-called shared finality gadget, we call this hotshot, where rollups can post basically pre-confirmed proofs to this finality gadget. And this finality gadget is essentially a very lightweight consensus. It's a proof-of-stake consensus, but these nodes don't execute. All they do is they see blocks submitted by the sequencers that won in the marketplace, and all they do is they say, I've seen this block, and I've signed it, and now it's going to be in this order, it's finalized, it cannot change. So they basically timestamp the block and say, well, this block happened, it cannot change afterwards. And this enables these sequencers to submit their blocks very quickly, and this has like a couple second latency. So these sequencers can submit their blocks to the shared finality gadget, and once it's submitted to the shared finality gadget, everybody has very high confidence that this block will actually be the eventual block that gets posted to Ethereum. Might still take some time until it's posted to Ethereum, but that's okay now because I already have this incredible high insurance from the finality gadget. And this has already a bunch of applications. For example, it can enable fast bridging. If I'm a bridge provider, then I can see the transactions that were submitted to the hotshot finality gadget. I can run a roll-up node myself in order to execute it, so I have full certainty on what the state is. And I see, for example, that I've received some funds in my bridge, and then I should be willing to release the funds on the other end immediately after I received them in the bridge. And in fact, we've demonstrated this with Across. So we had, I think we enabled like 2-second bridging without any sort of trust assumption. So risk-free 2-second bridging. Yeah, it also provides data availability sort of as an add-on, but it's essentially for free along with the sequencing fees. Yeah, so that's the hotshot finality gadget. In the last couple of minutes, I want to talk a little bit. I said there's this marketplace that basically sells the rollups rights, but designing this marketplace is actually kind of tricky. And there's a lot of details in how that works, and I won't be able to cover all of it, but I want to give you a couple highlights. And in particular, I want to focus on the key design goals that we had when designing this marketplace. And there's really two design goals. One of them is that we want to enable shared sequencing through the joint sale of rollups. So we want someone that basically wants to control 2 rollups at the same time to be able to bid on 2 rollups and to be able to control them, and that should enable shared sequencing. The other one is that rollups should only sell the sequencing rights if they can make more than running their own sequencers. So why would a rollup join this marketplace if it could run its own sequencer? Well, the idea is that they can make more money by joining the marketplace than they could on their own. So how do we enforce this second, the second design goal? Well, I'll get to that in a second. So yeah, the second design goal, keep that in mind, because I'll show you in a second how we're going to enforce that. So the first proposal is that, well, one thing that all these rollups could do, it's not what they do today, but it would be a minor sort of modification of what they do today, is that they could just run a so-called PBS auction, so a proposer builder separation auction, which means that the sequencer, instead of constructing the blocks itself, it basically just runs a so-called just-in-time auction in order to sell the block to anyone who's, or the block space, to anyone who's willing to build the highest value block. However, one thing that we can already do is that instead of having these auctions be separate, have one synchronized auction. So we basically synchronize the time slots. We say we sell basically, you know, say 12-second time slots at a while, and we have one synchronized auction, one marketplace where everybody can submit. And this is already better than having these separate auctions. Why? Well, because now someone can bid on 2 roll-ups at the same time, and they know that, oh, they're winning the auction for roll-up A, then they might know, okay, now I'm going to be willing to bid slightly more on roll-up B because owning, basically sequencing A and B together at the same time gives me additional value. So this is proposal 1, but it's still not perfect, because if you run this auction at the same time, you still might end up, even though you've bid on A and B, maybe someone outbids you in the last second and you just end up with B, but you didn't really want B on its own, you wanted A and B. So hopefully we can do better than that. So the thing that I was hinting at, so how do we enforce in these auctions, how do we enforce that the rollup is actually better off than it is on our own? And we basically use one tool, and this tool is called reserve prices. So what is a reserve price? A reserve price is a minimum price such that the rollup will only be sold if that price is met. So this essentially acts like the rollup was bidding on itself. And what is the effect of this? Well, first of all, what if this price isn't met? Well, then the rollup has to basically provide its own sequencer, its own centralized backup sequencer, and run that sequencer whenever the rollup isn't sold. Okay, and if, however, the rollup is if that price is met, then the rollup is sold. And this reserve price essentially just ensures that a rollup can say, you know, if it wants some railguards around it, it doesn't really actually, if there's enough competition, it doesn't actually even really need to set a reserve price. But if, you know, a rollup is conservative, they can set a reserve price and they can say, okay, I'm only willing to say if I get, I don't know, more than 1 ETH per block. But then they also need to provide their own sequencer. And this ensures, this single-handedly ensures that the rollup makes more by selling, because otherwise it just doesn't sell. And we can add some additional fees on the reserve price and bits in order to dissuade basically too high reserve prices, but I won't go into that. So the last point, you know, that I want to make is in the last minute is that, well, you know, I said that there's still this problem with these auctions where you might bid on A and B, but you don't win on the same time. And the solution to that is to run something called a combinatorial auction. And here the idea is that I can actually submit a bid that says, I want to buy A and B for 10. And I think I have an example of this. Well, so you can bid on any combination of bundles of rollups block. Each bid is the right to propose for that bundle of blocks in a specific slot. So for example, here, bidder 1 bids on 3, 4, and 10. And then bidder 4, so it bids 3 on A, 4 on B, and then 10 on the bundle A, B, and C. And then bidder 2 bids 11 on A, B, C, and 3 on C. And then you take basically the combination of these bids that gives you the highest bid overall. If you quickly do the math, you can, you know, see all the combination. You could sell A, B, C together to 2 for 11. But actually what's better is selling A and B to bidder 1. And so A, B goes to bidder 1, and C goes to bidder 2, and the total revenue is 13. And then the one final thing is, how do I split the revenue? Oh, it's not on here, but how do I split the revenue? Essentially, I split the revenue proportional to the individual bids on the rollups. Okay, so that's got messed up, but thank you very much. You can find more. We wrote a blog on this. I think it's if you Google HackMD Espresso Sequencer Marketplace design, you can read about all the details. And yeah, thank you very much.